Okay, please.
So, the topic of today's presentation is the robot and human from motion to emotion and implementation for rehabilitation and robotics. So, myself, Tripathi, and I'm from Wagatsuma Lab. So, first I would like to give the overview of the presentation. So, it starts with an idea, having motivation behind that, and then decide the subjective approach, that how we should approach for the problem, and then defining the problem and the objective approach for the problem, and then what will be the implementation platform and what exact method we will adopt, and finally the result up to the level what have been implemented, and the projecting future work, and the final so the implementation method is right now used as principal component analysis and uncontrolled manifold, and last is that creating an emotion model for that. So I will start with the idea. The idea is that the cognition of emotion and feeling based human learning and intelligence provide a new approach for human-like performance of robot. An integrative approach for motion and emotion will help in improving action and learning of the robot. So the motivation is like how does the cognition of emotion and feeling can be implemented into the robot? So the one prospect of human is like if we are in an environment and suppose we are trying to walk in a muddy environment, and if we fall, we memorize the pain and the way we have already tried. And the next time when we try, that feeling of pain and the related emotion used to be there in the memory, and we try to avoid that and we try to improve our emotion. So that is something as a motivational background that how we move. So regarding that emotion model, there are different research in area of neuroscience and psychology. So Ludox has proposed two-way pathway of emotion. The amygdala is mostly responsible for emotion. So the Ludox said that there are two pathways. One is that in the current context, amygdala produce some emotion, and the second way pathway of emotion is through memory. Means whatever we have memorized in terms of pain or any happy emotion, so that comes through the pathway of memory. And there are several abstraction level of emotion. One is that we have a decision making capability using emotion, and the second is abstraction level is that we have homeostatic regulation of emotion, and the more lower level is like we communicate with the people and show the expression and emotion. So the question is that if we fail to perform a task, like we took example of environment, muddy environment, and we are walking, so either we fail or successful. If we fail, we try for the success, and if we are successful, then we look that whether our success is with a proper prospect or not. Is just okay or good. If it is just okay, we improve it, and after that improvement, we learn the method which we have adopted. But the problem is not only at the emotion side, but problem is also how to try for the success. Having that particular feeling, how we try for the success. So in terms of motion and the successful motion, the problem is defined by the Professor Bernstein as a two exact problem. One is the using the degree of freedom, how effectively we use the degree of freedom, and the second one is the coordination of degree of freedom. So these are two problems that exactly defined in this area for a successful motion. So it's like that we used to be in an environment, we define certain tasks in that environment, and we as a body and brain, we try to achieve that task. So the task is the motion is as a means overlapping area of the environment, specified task, and our body and brain that act in that situation. So the subjective approach is more looking from the mechanical side, that how a robot works, their robots degree of freedom and robots work. And the second approach is that how our mind tackles these kind of problem to perform certain tasks, how the mind uses the degree of freedom and how it perform that task. So in that side, when performing the task, the emotion also comes into the play. So defining the problem and the objective approach is, there are three things. One is emotion. So the approach is to understand the problem, understand the emotion from the psychological point of view, and phenomenological, developing a phenomenological model of the emotion and implementing it to the robot. The second problem is the degree of freedom, how to minimize the degree of freedom to control the robot. And the third one is the coordination of this degree of freedom. So, and these three things can be implemented both on the robotics and rehabilitation point of view. So for our implementation, we are looking both point of view, on the robotic implementation also and in the rehabilitation also. So for robotic implementation, we have the now to implement it, and for rehabilitation we have some projects like a standing up motion project, and so we are looking for that. So the right now the progress of the project is, I divided into three parts. How much I have developed the implementation platform, and the implementation method, how much I have progress on it, and the last one like PCA and UCM, and the last one is the emotion, that how I have been developed in that till now. So regarding the platform, I learned that how to develop that development environment and the control of robot, sensor access, and the time-based control of the robot. So after learning that, we implemented the same thing for the standing up motion of the robot, and we analyze it along with the data, the human data also. We had the human data collected from So this is the human data collected from motion capture devices. So the analysis gives us the result that in standing up motion, the center of gravity shifted from a stable position, goes to an unstable position, and then again to a stable position. So if the center of gravity changes, then the motion has some problem. Means if it is not proper, the center of gravity don't follow that proper trajectory, then the task is not completed. So this is the human data captured using that device. So after this basic analysis, we had to move to the mathematical analysis, that how we can do the mathematical analysis for degree of freedom and synchronization thing, coordination of that. So there are different approach. I preferably looking for two approach. One is mathematical approach, that is PCA and uncontrolled manifold. So these are the references that we are currently following. And so what I did is, the robot has 26 degree of freedom. The robot has 26 degree of freedom. So we have to implement the PCA to minimize it. So PCA has some mathematical process, like we get this matrix A, that is, there are 26 degree of freedom, and theta varies with time. So this is a matrix. So we find covariance matrix, and then we find that PCA components. But the point is that if we find the PCA component, we find all 26 component, because there are 26 sources of the data. So we have to choose the top first K component which we can use. So choosing the top 6 K component, we have some mathematical process that gives that if we choose first K component, what will be the error. So it depends upon the task. Sometime even the higher error is okay, and we can have a less component, and we perform the task and it works well. So like there is one motion, that is the knee bend sitting motion for the robot. For the knee bend sitting motion, even if we take less component, it works good. Means the component is selected according to the retenance of variance of the signal. So even if the retenance of variance is low, it works fine. So I will show the video after that. So finally, the reconstructed signal we get from this reduced set of PCA. So how I implemented it, we got the robot data from experiment, and then we implemented PCA, and then finally we implemented it back to the robot. So in case of knee bend sitting, it's a very easy motion. So even if we retain 85% or 80% or 75% of the signal variance, we get this task successfully. But in case of sitting, like I explained earlier, that center of gravity changes. So even if there is a little abrupt motion, the task is not successful. And in case of walking also, some joint motions are very small but very perfect. If they don't, we cannot produce that motion. We cannot produce it, the task exactly, reproduce the task exactly. So in this case also, there is only one successful case when we take 100% variance. And these are the degree of freedom. Means if we take 100% variance, we use all 26 degree of freedom. If we take 99% variance, only 3 degree of freedom is used. So this is the task performed by the robot after the PCA. This is the knee bend motion that is performed even at 75% retenance of variance. This is tested on the web board and on the real robot also, because it was working fine on the web board, so I used on the real robot also. This motion is tested only on the web board because it was very typical to use on the robot. The moment I was trying to use, the robot was saying just ouch, or in the fall situation, reaches to fall situation. So I didn't use this on the robot. This one also this one is the case of walking, in which I am taking 99% variance, but it is not walking. It just moving its knee at the same position, but unable to walk. But the moment I take 100% variance, it even walks with that motion. So this was the successful case for walking. But because of not the reconstructed signal even in this case is not very perfect, because there are some small motions of the joints which is not very perfect after reconstruction. So the result is that if the ratio of reconstruction error is higher than the motion of the joint, it is not good, it is not controlled well. And in the earlier I explained that in knee bend sitting case, COG is all time on the body, so is okay. In sitting chair sitting case, if COG goes out of the body, is not perfect. And like walking case, if the motion is small, there are some small perturbations that, so the less degree of freedom will not work. So the PCA result and the future work, result I already shown. The future work is that analysis with the human data for rehabilitation purpose, and human data is collected by EMG and motion capture, and the motion analysis, other motion analysis with the robot, and they are involving some other method for the analysis along with PCA. The second approach is the UCM approach, that is uncontrolled manifold approach. In this area I have just progressed with the theoretical understanding and creating some basic program. The theoretical understanding is like, this is the plane of the motion corresponding to the degree of freedom. So some degree of freedom contribute to the motion and some don't contribute. So these are those components which don't contribute are uncontrolled parameters. So they are perpendicular to the surface, and those who contribute are the parallel to the surface. So we distribute it in two components, and then we do some mathematical processing to define it. So the future work again with the UCM is dimensionality reduction and implementation to the robot, and the analysis with the human data. The last, I think, more interesting for you is looking for emotional prospect. So emotion is considered as a philosophical concept also, as a psychological concept also, and a neuroscientific. But we are looking more engineering aspect, how we can implement it to a robot. So my perspective was that is coming from a clinical neuropsychology aspect. These are the papers that says that in clinical psychology, they say that emotion of good and bad is learned through experience and memorized for object and event. Means in the environment we have some object and we perform, there used to be some event. So the good and bad memory corresponding to the object and event is memorized, and we perform according to that memory. The next time when we have that event or object, we perform according to that. So how to implement this concept was one point of view that I was looking for. So the pull-check model is the distribution of emotion in the wheel. So I considered one dimension of that is that what type of emotion is there is decided by the angular position, and what is the strength of the emotion is defined by the radial position. And I took another dimension which connects two objects or two events through some action in the environment. So this is the three-dimensional space in which there will be an object or there will be an event which a robot has to take and robot has to perform corresponding to that. So there are some definition of that, like if there is some object, so object will be associated with some these values UVW. So we supposed to let the robot memorize these objects and associated values also. So once the robot has memorized the object, image of the object, or if there is a the event or object, maybe some sound. So if robot listens some word, it will have some associated value which it will recall, and according to that it will perform some action. So the small actions collaboratively will be an event. So an event is the sum of small actions. So those small actions are E1, E2 and E3. And I said earlier that there is a third dimension, that is the vector of the action. So that third dimension of the vector of the action defines the E1, E2 and E3. So this is something that actually I was expecting to implement, but due to some lack of confidence and due to some other situations, I could not implement yet. But hope soon I will be able to implement it. So for that we have to define some robot task and robots event that can happen in the environment. So I categorize those events and in these categories which the robot can show, and then finally I supposed to implement it. So this is the related to the emotion that I want to do. So this is the expected publications that I look for in these two areas. And lastly, I have to acknowledge that with the help of Tachibana Sensei and two of my master's student colleague, Asukikun and Inyoku, and of course Kazuma. Last but not the least, Professor Wagatsuma Lab, his guidance. So,
Okay. Okay. Time for question and then discussion. Please.
Well, it was very interesting, this motivation that if I have some experience or something happens to me that I memorize it, and then all the time I evoke some feelings with this. You know, I'm talking about this relation between memory and emotion. I would say I was just coming here, and I was flying a lot in my life, and all the time when a little bit shaky situation on the plane, all the time I memorized the worst turbulence what I ever had. So all the time I expect the worst turbulence, but maybe sometimes doesn't happen. And that time I have some feelings. What I want to ask you is that, let's say if you have some bad experience, and then afterwards you have the same situation with not so bad experience. I'm not expert in psychology, but I believe that there is some forgetting factor about this.
yeah.
So I'm not sure, but maybe probabilistic model or something could be implemented into it. That, let's say, once it's like earthquake. It's like I all the time I'm scary about the earthquake here, but let's say if the not coming, I forget about the earthquake. So just one remark or your opinion would be interesting for me. How to implement the forgetting factor into this problem? Is that worth it to think about this, or because it's a very interesting idea, very interesting.
There can be 2-3 ways to look at the problem. One is that what is our attention at the present? If our attention is different and in the environmental context, then we may not recall that memory. It will be forgotten. And if it happens for the long time, then we don't remember it. We remove that memory. But again, if the same situations happened repeatedly, then that factor becomes more strong and strong. So in a kind of neural network approach, we have achieved some level. The neural network community has achieved some level, the forgetting. So if that kind of network we try, we can implement that part. I haven't tried it, but if we intensely look for the forgetting aspect, then we have to implement that.
I wouldn't say that the implementation is there can be implementation based on rules. There can be implementation based on probabilistic approach or also by neural network. But what I'm saying is that maybe some people have different approach to this. You know, some people like, you know, if some person, I don't want to say woman, saw a rat, then she's like, you know, she's like very quickly she's coming up. But I when I see rat, you know, it's not getting my memory out. So it also can be a fact of personalization, is forgetting something. Also the implementation of forgetting is very interesting because you use remove, and the remove is total forgetting, or and when it comes back, it's like, you know, it's not totally forgetting something.
If we talk about the scary thing, in context of a scary thing, forgetting can have 2-3 dimensions. One way of forgetting is like, I was scary for the rat, that it can bite me. But suppose my parents bring a rat and they kept it with me, and they show me that how I can have the rat, and then I forget that.
Yeah.
That is one aspect. The other aspect is...
So other emotions can suppress the previous...
Yes. The other aspect is, for the long time I haven't saw the rat, and I forget the image of the rat. So the next time I saw the rat, I redefine the emotion or feeling with a totally new way. That is another aspect. The third aspect of the forgetting is, it is mostly dependent upon the attention. So even if the rat is there, but there is something more scary than the rat, I don't care about the rat.
Yes.
So there can be several aspects of forgetting that thing, but it depends upon, like we working in the robotics field, so we try to look from the robotic point of view, what can be the aspect of forgetting for the robot. So so in that sense, if we look from the robotic point of view, then we think, what can be the situation the robot should forget something, whether means if it's like we have to define something, that what can be the situation that the robot should forget something. Like the robot has a lot of the memory, the robot has a lot of the faces, some good and bad experiences with the faces, but now in that environment one person has gone off, so the robot is not seeing that person, so it should forget that.
Yeah, but everything what you're saying is leading to the situation that maybe the forgetting policy can be different to different people.
Yeah, different to different people.
Yes, that leads to maybe personalization of
personalization.
Yeah. And so that was only one point. Second was that you were talking about the model of behavior of the human will be, or you say it precisely, you said human-like behavior of robots, right?
Yeah.
Okay. Now I want to ask is that there are some maybe studies who are saying that how we expect of the robot to behave. Are you totally sure that we expect of the robot to behave like a human totally, or you know what I mean? That
I understand.
it's you know, if I would have a robot who would be exactly like me, it would really, I would be very bad to him, because I know that I have many mistakes and so on. So maybe I need a person who is behaving me and, you know, making me good and so on and so on. So the question is that that if because what is very interesting that we were talking about 3 years ago about a companion. Now we are talking not really about companion, we are talking about assistant.
Yeah.
So we are moving from the I'm moving. I feel that in this area we are not so convinced about companion, and we are more talking about assistant to help people, not to be a companion. We can mentally help people to talk to and so on. So what's your opinion about this problem, because it can be also touched about?
Actually, when we say that we like the robot to perform like a human, is not exactly that we say that the robot will behave like a human, but it's just to say that the robot will have certain aspect in which it will behave more like human. Maybe not exactly like human, more like human. So now, if I consider my approach, then what are the things the robot should do like human? What are the aspects? So I am looking for an aspect that if the robot is performing some task in an environment, the task may not be very big task like getting fall and standing, but the task is like, suppose the robot want to have in terms of motion. The one aspect is the robotic motion. So how the robot perform the motion like human. So that is the consideration. Like in our case, if we want to reach to a certain point, we have already learned with the experience that how I can move my hand softly to reach a certain point. And there is a strong brain calculation, neural calculation behind that. So what are the mathematical strategies that can be adopted for the robot that it can do the same thing? And that is defined as a problem of minimization of degree of freedom. So even the robot has many degree of freedom, but that can help to do some complex task. But how we can minimize those degree of freedom, that if the robot has to do some small task, it need not to use all degree of freedom. It just needs to use some degree of freedom.
But the degree of freedom is connected also with the complexity of the control.
Yeah.
So that's good that we have to reduce to control easily, and also the movement should be soft.
Yeah.
So we have to find out.
Yeah.
I have just two remarks, and then my final. I have remarked that you were talking about PCI. I would like to take your attention to so-called OYA networks. Professor Oya was a person who, I don't know if you know the OYA network. There are neural networks who are in fact calculating the PCI. And the main issue is that you can run it parallelly. So that's one the advantage of the OYA network. And second is regarding to this Plachkin emotion model, that it's really the temporal part of it. It will be very interesting. And my final question, which is wrapping up the question, is that about the programming and implementation. Would be very interesting that if, because I know how in Japan exactly, but the question is that if you are heading into some integrated software environment, which when you finish PhD or you some other people or masters will be very, very interesting if you or maybe we can put together something which would have some architecture in software architecture, which could be enriched. So you make one blog, and some other people can make other blog, and they can reuse your blog, and the other can reuse your blog, and that's very, very important things, because when I know the situation on the research lab, they don't care about it. They work in something, and the same is in my lab. And it's last 2 years we are starting to bring our attention and then to this problem, and we are now trying to not hire but collaborate with computer scientists. And in computer science they have a special branch called software architecture. and they work in this way that, let's say, Maria is expert in emotion. She says what she wants to do, and he is analyzing, or she's the architect is analyzing and say, you have to do it this way. Put this block to this block to this block to effectively collaborate. So I don't want to say unification of computer languages, but maybe the basic framework would be very interesting, and it would be very nice if that would lead to integrated software.
I think that is a good idea. Yes, that in which direction we can proceed.
I know that you say that's not easy.
Yeah,
But-
I didn't mean that, something more, a little more. I didn't know how to express myself, sorry.
Is there any comment? Or
Yeah, I wonder, very nice talk. And if you go to slide 5, for example,
Yeah, sure.
I wonder if there is any connection to the reinforcement learning, because because it seems to me like your work is some kind of extent of the reinforcement learning, or if you
My
can-
understanding, that the mind has different strategies, and the reinforcement learning is one of that. We cannot avoid that. But there are other strategies also. So the right now the
Well, the question if we don't have just reinforcement learning in different forms,
yeah
because all the time we have a reward,
yeah
and the basic concept of reinforcement is reward and the punishments involved. So the question if we don't have only reinforcement with different form, that's the only question.
That can be one way, and the novice way to implement it. If we take emotion module as a reward giving module, then implementing reinforcement learning from that prospect is one of the good way to implementing this. I agree with that, and in fact I believe in that we can do that.
We all want to be happy.
Yeah.
That's reinforcement.
Yeah. Thank you for giving my attention to that direction.
And also, in your future work, it's 29, but it
Yeah.
doesn't matter. Like, yeah, this. So you have these environment causes, and I think it will be very hard to implement only this part of the rule. If I say this, like, for example, how would you implement empathy with someone sad? You have to, from the robotician point of view, firstly, you have to recognize that there's some face, or there's a person, then we have to recognize the emotion, then how will you describe empathy?
Actually, this is not actual part. The other part is the reference from a paper. Sorry I could not mention that paper here. So in that paper, they have defined the human strategies, the
So
human approach.
this is
I have minimized it considering the now platform. So if I look at the first cause, the fear of collision or fall, so the robot has some feedback that we can use.
Yes. And
So-
how he will know empathy?
Yeah.
Like it's
But yeah, okay, empathy. Empathy is, yes, he has to memorize some face and he has to associate some feeling, that kind of.
because, for example, if you have being in dark, it's very easy
Yeah,
to
easy.
implement for
To
now.
implement, yeah.
Also, fear of collision,
Yeah.
maybe it's easy.
Easy.
But then we have some.
For example, if he doesn't see him a long
Yeah.
time, he can be sad.
Yeah.
Yeah, like receiving love and affection. It means like, I don't know, touching
It's
this
like-
touch sensor.
One aspect was like when we use the petting. So if we touch the robot like that, it's a kind of receiving love. So
Uh-huh.
so I consider that one.
Actually, it's very nice what you wrote, because I think I like it very much, this table.
Because when my student did this,
Mm.
like maybe 90% the same, But yeah, I can show you a video.
That will be great.
But you have some more things, so I wonder because we couldn't we couldn't invent so many things.
No, but I think what she did was only selected parts of this,
Yes,
and it's very complex now.
it's very complex. In human case, is a more reason causes and more reactions. But I put it only considering the platform in my mind that what we can implement.
Okay. Thank you very much.
Thank you. It's really great.
Very much.